Let's continue on in Chapter 5. This is talking about the startup in Windows 10 and later. And all NTFS computers perform the following steps when the computer is turned on. Power on, self-test, post, initial startup, bootloader, hardware detection and configuration, kernel loading, and user logon. It really is interesting when you start digging into it how many different places you have to go look to see what's actually loading on your computer. So it's just not all in one file or one program. Now our startup files for Windows Vista, the NT LDR program, NT loader. Program in Windows XP used to load the OS has been replaced with these three boot utilities: the boot manager, WinLoad, and WinResume. Windows Vista includes the BCD editor for modifying boot options and updating the BCD registry file. And the BCD store replaces the Windows XP boot INI file. So you can see it keeps evolving. Now for Windows XP, you got your NT loader, NT LDR, boot INI. If you're not familiar with INI files, I don't know if I could actually locate it. Yeah, there is one in Windows 10. To be honest, I haven't that exposure. If I can't locate it relatively quickly, then I'll just find any INI. Kill that. And let's go in here. Okay, let's just kill that and see if we can find any INI. Here's one. Store password INI. That can't be good. I assume that's not storing it as text, but let me go to this one, nvtimings.ini. An INI file is just a text file, and I always have this up here telling what this particular setting relates to. So this version, and then this, under the version, the signature is equal to this. This used to be how they used to maintain all this information back in the early days of Windows. Everything had an INI file. If you needed to change something, you just went into this INI file and you changed it. And those all look the same. There's hardware properties. Let me open that. That's strange. Let me open it with WordPad. That looks better. Boy, that's pretty unstandard for an INI file. So, but again, it just stores off system information. So if you don't want to store it in the registry, you can store it in an INI file. So that's what they're talking about when they're talking about an INI file. Basically, if you edit in Windows XP, you edit this file, then that changes what loads. NTOSKRNL, NT operating system kernel, BOTVID boot video, I'm assuming, .dll, DLL. Of course, an INI is a text file. EXE is an executable you run, of course. DLL usually consists of libraries, so it's a code. Typically, it's shared libraries. So maybe you want to access this from multiple executables. So you put it into a DLL so you can share all that code. It's one of the methods of sharing code. HAL, HAL, not sure what it even stands for. Bootsect.dos, ntdetect.com, ntbootdd.sys, pagefile.sys. Then you also have device drivers. These contain instructions for the operating system for hardware devices. Here's system files. Not too exciting, but NT operating system kernel.exe is the XP executable in kernel. Kernel is usually something important. It's like the main program. NT kernel LPA, the physical address support program for accessing more than 4 gigabytes of physical RAM. At HAL, we refer to the hardware abstraction layer. Win32k.sys, the kernel mode portion of the Win32 subsystem. And then all these DLLs, looks like NT DLL, system service dispatch stubs, executable functions, and internal support functions, and all the rest of these are core Win32 subsystem. Well, contamination concerns with Windows XP. When you start a Windows XP, several files are accessed immediately. Last access date and timestamp for the files change to the current date and time. So it destroys any potential evidence. That shows when Windows XP workstation was last used. That's what I was talking about. Depending upon the system, just booting it up changes files. At least their date and time. Now, we have something called virtual machines. I have a virtual machine on this computer where I run Linux. Enables you to run another operating system on any existing physical computer, known as a host computer, by emulating a computer's hardware environment. When it says another operating system, it doesn't have to be different. You can run the same operating system, but you just want to run it maybe in a protected environment. Virtual machine is just a few files in your hard drive. You must allocate space to it. When you create the virtual machine, in some cases, just like they say, there's a few files, maybe a folder, and that's where the operating system is contained. So if it gets infected, like you're going out and surfing something and you get an infection, you just delete that files, that folder, and then you're back up and running once you redo the virtual machine. Virtual machine recognizes components of the physical machine it's loaded on. Virtual operating system is limited by the physical machine's operating system. One of the examples of the component is suppose if you had a drive you're connecting and you want to be able to access that drive. Here's a virtual machine running the host computer's desktop. This looks like Oracle VM VirtualBox. There's two big ones, VMware and Oracle's VirtualBox. Now, in digital forensics, virtual machines make it possible to restore a suspect drive on your virtual machine and run non-standard software the suspect might have loaded. From a network forensic standpoint, you need to be aware of some potential issues, such as a virtual machine used to attack another system or network. The one I've been using lately is virtual machines from OS boxes. Not sure if I'm exactly really pleased with the site, but they got VM images. These are virtual machines already designed for you, already set up. And so you got VirtualBox here, which is Oracle's, and you got VMware, which is, of course, VMware. You click VMware, and let's say I wanted to, experiment with this. Kali Linux, Kali, however you say it. This is a Linux distribution for penetration testing. So if you wanted to get comfortable with this, prior, I know a couple of you are going to penetration testing, right? Yeah. If you want to get comfortable with that prior to entering that program, this is a big one. Tons of utilities on here, so you can't think, well, I'm going to go out there and just spend an hour on it and master it. Lots of different programs on here. So it's kind of a distribution full of a bunch of other programs. I don't know if I can get a list of the here it is, Linux tools. Tools listing. Here's all the different tools there are. Some of these I've used, some of them I haven't. Tons of programs. Probably take you 5 years to master all these. To use them, not that much. But again, to master them, take you a long time. Well, you could work at setting that up and everything, or you could simply install the VMware free player and download this image and be up and running. So it's kind of an easy way to get everything set up without spending a huge amount of time. Some of these I haven't even heard of. Gen 2? Whatever that is. Highly flexible source-based Linux distribution. You'll find most of these are Linux operating systems, because Windows requires a license, so you won't find typically you won't find Windows out here legally. But that's a virtual machine. What they look like. Bring up mine. This is one I used for the Introduction to Linux class. This is Fedora. So it's already been set up. So I just click Play Virtual Machine. Reason why I said I wasn't sure if I was exactly crazy about this is because this OS boxes, the user ID they gave, was supposed to be a root account where you had total access, and it's not. And I doubt if I can see this well enough to. Okay, how do I zoom in? Control. Can't see it. Almost looks like plus plus. But again, it allows you to run a Linux operating system, so you can be up and running in just perhaps 5 minutes time. You can shut it down, or if you just close it, you can just suspend it, and then in theory, it just continues where it left off. I say in theory, because sometimes they do weird things. You have to restart them. Virtual machine used to attack another system or network. The same tools that you use for penetration testing, somebody could use to attack a system. So, now here's creating a virtual machine. Common applications for creating virtual machines: VMware Server, VMware Player, VMware Workstation. The only one I've really used there is VMware Player. Couldn't tell you what those other two products do. Oracle VM VirtualBox. I have mixed results with it. Sometimes it works fantastic. Other times, I don't seem to have much luck. I tried to get a server up and running. There's a package called edX, and its own little server. Tried to get up and running. Had a nightmare trying to use GitHub and this VirtualBox, and never could get it figured out. And I wasn't the only one. There was another individual that were working together to support this product, and he couldn't get it either. So I don't know who they finally hired, but I told him I couldn't figure it out. So I couldn't help him. Microsoft Virtual PC I've never used. Hyper-V I've enabled, but that's about the extent of what I've done with that. Now, using VirtualBox, it's an open source program, and they got a link here for the download on that. Consult with your instructor before doing activities using VirtualBox. And then summary. When starting a suspect's computer using boot media such as forensics boots, CDs, or USB drives, you must ensure your disk evidence isn't altered. The MBR, the master boot record, stores information about partitions on a disk. Microsoft used FAT12, FAT16 on older operating systems. Find a hard disk capacity, use the cylinders, head, and sectors calculations, CHS. When files are deleted in a FAT file system, the hexadecimal value 0x05 is inserted in the first character of the file name and directory. NTFS is more versatile because it uses a master file table, MFT, to track file information. Records in MFT contain attribute IDs that store metadata about files. And NTFS, alternate data streams, can obscure information that might be of evidentiary value. File slack, RAM slack, and drive slack are areas in which valuable information can reside on a drive. NTFS can encrypt data with EFS and BitLocker. It can compress files, folders, or volumes. Window Registry keeps record of all your attached hardware, user preferences, network connections, and installed software. And virtualization software enables you to run other operating systems on a host computer. Questions on any of that? Let's go on to Chapter 6. There, it finally went down. Chapter 6, Current Digital Forensics Tools. Our objectives of this chapter: explain how to evaluate needs for digital forensics tools, describe available digital forensics tools, List some considerations for those digital forensics tools. Um, there's a mix of software and hardware in here and so forth. Describe methods for validating and testing those some of those tools. Now, evaluating your digital forensics tool needs, you have to think of open source tools. Best values for as many features as possible. That Kali Linux, however you say it. I keep thinking Kali from the Indiana Jones films. I don't know if that's named for that reason. Wasn't that Kali the bad evil Indian god? Um, it does have some bad stuff in it. So that Linux distribution. Um, if you're not collecting items for a court case, then maybe that's perfectly fine. They're pretty good tools. That's what a lot of the hackers use and so forth. Questions to ask: what operating systems does forensics tool run? If you got one that's designed for Windows, it's not going to run on Linux without some kind of modification. Is the tool versatile? Can the tool analyze more than one file system? Can a scripting language be used with a tool to automate repetitive functions and tasks? It's interesting how some of the security programs will have you majors, degrees around. Will have you take programming language. Some won't. Down in Rose State, that program they have down there, they have you take a programming language because you have to know a little bit about scripting in order to understand perhaps what they're doing. What are the hackers doing? Because really, like a script you might run in Linux is kind of like a programming language. One you would run in DOS is not really like a programming language. It's kind of got some of the functionality, but not what you might think. It's been so long, I may not be able to remember, but we'll see. Let's see, run it .bat. Create a file, yes. I don't know how to list a file. That's bad. It's not list. It's not cat. That's Linux. Yeah, obviously I don't got some of it right. Nope, it's not list. It's been too long. Batch files used to be how you'd run programs. How you do settings, how you save off log files, and so forth. The echo high should print high to the screen. When you redirect it with greater than, goes to the file, so the right side file. I thought the greater than appended on the end of it, but obviously I'm wrong. The directory, dir, just shows the files in that folder. Let me try that one. dir. That's a that's a directory. That is strange. I'm probably forgetting something. It seems like you had to put some kind of quotes around it, or I can't remember. But it does not have a whole lot of flexibility. On the other hand, the scripting that goes along with Linux does. It's a complete programming language you could have inside of a script. So, and if you're going to work a lot with Linux, if you don't understand programming, you're not going to understand the scripting involved with it. I think I already brought down the VMware machine, the VMware. It's talking about can a scripting language be used with a tool to automate repetitive functions and tasks? But that really opens up when you have a scripting language in anything, you can do anything. So if you got a software package that has a scripting language, you can fly to the moon. It just opens up so much. I suppose there might be some that have very limited scripting, but this is true with networking too. Our old network engineer, he started taking one of my classes. Kept getting called out because of system problems, but he started taking one of my programming classes because you have to know scripting in order to do some of the items on that. Got asked by our webmaster to do some scripting using, what in the world is it called? PowerShell? I think it was PowerShell, which I know nothing about. Yeah, scripting language based on .NET. Helps system administrators, power users rapidly automate tasks and manage operating systems. Keep thinking I need to learn that. I hear the name pop up more and more. Probably if you're only in networking is where you'd really use it. Maybe the forensics analysis, penetration testing, but does have automated features. Some of these processes take a while to run, and if you can automate them so they all run during the night, that simplifies it. What is the vendor's reputation for providing product support? That's kind of invaluable, because if you can't get something to work, you like to be able to have somebody to call. Now, our types of digital forensics tools, we've got hardware forensics tools, range from simple single-purpose components to complete computer systems and servers. Software forensics tools, got types, command line applications. That's what I was showing you here over this. Where you're sitting here and you're doing these commands here. That's bad. All I can remember is directory and echo. Linux is even worse than that. Tons of commands available. Then there's GUI applications, so that you have just nice click this file menu, so not as hard to learn. Software forensics tools commonly use copy data from a suspect's disk drive to an image file. Now, for our tasks performed by the digital forensics, it follows guidelines set up by NIST Computer Forensics Tool Testing, CFTT program. Not sure if they'll have that in your program up in South Dakota. All right. There's a real focus on NIST, and I can't stand NIST. It's very boring. Reading some of their documentation, you think this stuff's snoozer. That stuff will really put you out. But again, you come up with guidelines. Guidelines are not usually exciting. Got your ISO standards, which again aren't too exciting. They state digital evidence first responders, DEFR, should use validated tools. 5 major categories: acquisition, validation, verification, extraction, reconstruction, and reporting. Oftentimes all done by the same package, but not necessarily. Acquisition, making a copy. Our subfunctions, we've got a physical data copy, logical data copy, data acquisition format, command line acquisition, GUI acquisition, remote, live, and memory acquisitions. Some of them may just copy what's on your hard drive, but they don't get what's in your memory. Need some of them to do it remotely, so that if you're extracting something from Google servers, Google's probably not going to let you seize their servers. Probably all kinds of lawyers that stop that. So you have to access it remotely. Two types of data copying methods used: physical copying of the entire drive and logical copying of a disk partition. And then the formats vary from raw data to vendor-specific proprietary. And I think you looked at some of that in that lab on how to create that. You can view a raw images file contents with any hexadecimal editor. Might not be meaningful, but you can view it. That's true about any file, really. Hexadecimal is how you can view anything. This is what a JPEG looks like in WinHex. Now it starts with a certain structure, and I couldn't tell you what a JPEG starts with. But somewhere in here, unless this is just this file, I guess. This first part here helps determine, I think, what type of file it is. It's been too long. I don't remember what it starts with. Looks like it starts with a signature FFD8FF. So again, these codes right here, if you were doing a lot of it manually, would help you to figure out what kind of file you're looking at. Because when you copied it, you just copied a bunch of bits, bytes and so forth. And so you're looking at this and you're trying to see what you have to work with. This would tell you have an image file. And since it doesn't have the length of the file embedded, we need to find a JPEG trailer, which is FFD9. So again, that's why you use a hex editor. Every file seems like it has different formats. Different codes. Here's a bitmap. Signature format. The BMP files start with a signature BM, which is, I guess, this 42 and 4D. And the next 4 bytes contains the file's length. So these right here. 16 to the 0, 16 first, 16 squared, 16 to the third. See, I don't think I'm reading this right. Oh, they talk about how to do it down here. Or maybe I am. 4DF6. Where did D go to? But it is in hex. So you'd have to convert that, see what size is, and so forth. Tedious, isn't it? You obviously wouldn't want to sit there and explore a complete hard drive, this way. That's why we have tools. For acquisition, idea is create smaller segmented files, not just one huge file. Remote acquisition of files is common in large organizations or servers you don't have control over. Popular tools such as Access Data and Encase can do remote acquisitions, forensics drive images on a network. See, and I don't know how that's stored out there, like in Google's case. When you have your files out there, or Amazon, I should say. Because Amazon one does some huge hosting. Is if you have your files stored out there, if you got your own space, where everything's contained, or if it's mixed with other people's. If it's mixed with other people's, I don't know how they'd do that. How do you separate? If you've stored parts of your files over here on my segment, then it seems like that'd be pretty challenging. Maybe they keep them separate. Now, validation and verification. Validation, way to confirm the tool's function is intended, and verification is to check to make sure that data you pulled is correct, matches your original. And it says by calculating hash values, there's another method. Related process is filtering, which involves sorting and searching through investigation findings to separate good data and suspicious data. You can do this at the file level. There, during the last election, or before the last election, there's all that uproar about Hillary Clinton's emails and so forth. And then they seized, what's his face? Can't think of his first name. Her aides or something. His last name's Wiener. You know who I'm talking about? Yeah, they seized his laptop. Found out he had downloaded emails from her server onto there. And they were searching his server for those, any emails that were official business instead of like family photo type things. They came back pretty fast. And I'm sure that they had the best forensics tools at the FBI. So I'm not questioning that. But it seemed like extremely fast how it came back. But there is methods of verifying that the files are the same. So they could exclude easily maybe all the files that they've already went through. Because if they didn't, there was no way they could have went through all those emails during that short period of time. So they probably excluded a huge amount of them using tools. As far as I know, Windows doesn't come in with a built-in tool for that. There is a built-in tool for that in Linux to see if two files are exactly the same. So again, separate your good data from your suspicious data. In his case, besides the other illegal stuff he was doing, suspicious data would be brand new emails. Now we got sub-functions, the hashing, the CRC32, MD5, SH1. These are all secure hash algorithms. Filtering based on hash value sets. You analyze file headers, discriminate files based on their types. This is what we're just looking at. How a JPEG always starts with a certain header. That's how these programs will determine what type of file it is. And if possible, it'll try to recover whatever it can. National Software Reference Library, NSRL, has compiled a list of known file hashes for a variety of OS applications and images. National Software Reference Library. Oh, it's an ISO file. Hash converter, Windows GUI tool. Oh, but then they have this down here. It has been broken out into two separate projects since most of the people who were interested in the server wasn't interested in the client. Okay. Doesn't look like it's an online tool. It says this maintains a repository of known software, file profiles, and file signatures for use by law enforcement and other organizations involved with computer forensics investigations. The NSRL collects software from various sources, computes message digests or hash values from them. 33.9 million unique hash values. It's pretty big, actually. Part of like virus detection and so forth, we'll use some of these signatures to help you figure out if something's valid or not. I want to show you one, but obviously I can't. Many computer forensics programs include a list of common header values. With this information, you can see whether a file extension is incorrect for the file type. You can go in. I wonder if I could download WinHex. WinHex. zip file. Setup. C program files, that's fine. Install into that, yes. Create program shortcut. Yeah. Run program. Okay, so we got WinX here. Assuming I can grab that. There it goes. Okay, so I'm going to do a file open. Go to libraries, pictures. I got a picture there. Remember how that says FFD8FF? But you can change these, and I don't remember WinHex. I think I just start typing. So like one you start changing bytes, and it destroys the header information. Make sure we're updated. Yes, I do. And this is 1511. It's got a JPEG extension on there, but now if I open it, can't open it. It's been destroyed because part of it's been overwritten. But if I went back here and I typed, now I've destroyed it completely. Undo. Okay, now let me type. FF, change it back. Valid. That's curious. Invalid file, user.txt, do not proceed. Let me close that and open it again. It's already been opened. Close that. No, don't save it. Close this. FF. Let's see if it'll let me save it now. If it doesn't let me save it now, I don't know. Did that time. So I come over here and I try to find my file. I'm probably looking right at it. There it is. See how it's back? But again, very tedious, and you have to know what you're really doing. And I know about the headers, and that's about it. But every file has a different header. You notice over here, sometimes they give you a clue, JFIF. That would tell us it's JPEG. So even when I destroyed that one bit of byte or that byte there, then it still allowed me to see what it was. Where's my documents? There we go. There's an MP3 file. Couldn't tell you the header information here. What's here, so forth. You Google it. If you want to know what the file header information is, unless you just got a fantastic memory, you go Google what it is and so forth. If you look at how many bytes are in here, though, tons of bytes. So if you had to reconstruct the file without a tool, it'd be a challenge. But anyway, many computer forensics programs use that list of common header files. With this information, you can determine you can see whether the file extension is incorrect for the file type. Most forensics tools can identify header values. I have a student in one of my classes, and she, instead of uploading a Word document, she uploads a Word document with no extension on the end. I don't know how she's doing it. Maybe she's doing it over in Mac. I don't know. But somehow she's deleting that extension on the end. At first, it's just like, what in the world file is this? And then I just started downloading it recently and renaming it, putting a DOC on the end. I'm not sure if it's actually a DOC, but that allows me to open it up in Word. One other student that uploaded something recently, and I had no kind of clue the extension at all on the end of it. But again, if I was real curious, I could have went out there and there's databases, all this lists that kept. I didn't care that much. I just gave him a 0 and said resubmit it. This talks about the file header contains JPEG. We already talked about that. Error message is displayed when trying to open a JPEG file in Word. So file filter DOCX cannot be opened because there are problems with the contents. But if you open that DOCX in this, and you get this file here. So what they're meaning is you just change the extension on the end. The extension on the end is what tells Windows what kind of file it is. And to a certain extent, you'll see that same type of concept applied in parts of Linux. Not as widespread as Windows. Then you get extraction. Recovery task in digital investigation, most challenging of all tasks to master. Recovering data is the first step in analyzing an investigation's data, or recovering data. Now, our subfunctions of the extraction, you got data viewing, keyword searching, decompressing, uncompressing, carving, decrypting, bookmarking, and tagging. Keyword search speeds up analysis for investigators. And it's just like you'd think over here. When you do searches here, a lot of those tools are like that. They allow you to do searches. But they allow you to do searches based upon file types oftentimes. So you can just bring up all the images, all the JPEGs. Again, good tools are not based upon the extension on the end. Because if I had an inappropriate picture, and I am, let's say this was something illegal, image-wise, and I didn't want you to be able to see it, or even somebody getting on my computer see it. I can right-click on this, choose rename, and change the JPG on the end as DOC. Now, I have not changed the header information in the hex. That's interesting. It still has that preview there. Okay, now it's gone. Did not automatically refresh. So somebody coming on my computer thinks that's a Word document. Somebody who's not very knowledgeable on computers, if they double click on it, bring it up in Word, and it'll look like it's corrupted. What should send out warning signals though if you knew anything about it? And I know it's kind of small. Down here it says JFIF. That would tell me it's a JPEG. But that's what we're talking about is those tools are such that they should be able to identify it based upon the header information, not just the extension on the end. Let's see. This gives you an example. Enter search words. Nucleic, if I'm saying that right, acids. Then you do a search. That's obviously not going to help you very much with an image. And for this type of search, this would be like more if it's going through text files, Word documents, and so forth. And this talks about the deleted file search configuration, case sensitive, include folders, match whole words only, multiple streams, file carving. From an investigation perspective, encrypted files and systems are a problem. Many password recovery tools have a feature for generating potential password lists for a password dictionary attack. If a password dictionary attack fails, you can run a brute force attack. Password recovery tools generating password lists. Sometimes this may be based upon a dictionary, but that kind of merges over into the brute force attack. But you assume that somebody's using a dictionary term. This last weekend, I created an account somewhere. I don't even remember where it was at. And I was trying to enter in happy as part of my password. It didn't let me. It said that's in a dictionary. So I can't use it. I was quite disappointed. I was looking for all the free packages for the cloud-based applications, trying to see what's out there and so forth. But I had to choose a different password. I don't even remember what I chose. I'm not sure if I wrote it down. I have my happy password that's not very secure, just because I don't care if anybody hacks into those sites or not. I'm just playing anyway. My real passwords are more robust, but again, it can go through a dictionary. You can come up with different combinations. You can type in somebody's information, their birth date, pets' names, and it comes up with all kinds of different kind of combinations along with those. So you got password dictionary attack. And there's a brute force attack, which may use a list. Sometimes just brute force goes through and generates all the possibilities. There was one, I think it was an Excel file that a user had lost their password to. And we had a program that we sat there and ran, and it tried every combination until it got into it. I think we had it running for 2 or 3 days total. As they went through and brute force tried everything under the sun. You know, when I say everything under the sun, first it'd try letter A, then B, then C, and then get through all the letters. It'd be A, B, A, C, and so forth. If it had a complete sentence, it probably would have took us a trillion years to get their password. But as it was, their password's only like 5 or 6 characters. Reconstruction. Recreate a suspect drive to show what happened during a crime or an incident. Method of reconstruction: disk to disk copy, partition to partition copy, image to disk copy, image to partition copy, disk to image copy, rebuilding files from data runs, and carving. To recreate an image of a suspect drive, copy an image to another location, such as a partition, physical disk, or a virtual machine. It all depends on what kind of resources you have there. At training I went to up at Johnson County Community College, where they have lots of money for their forensics area and so forth. They had swappable hard drives, so that when they rebuilt something, they didn't do it on a virtual machine. Virtual machine is good, but it has some limitations. You're creating kind of this virtual environment, which maybe is not exactly the same as what they had. So they had those swappable hard drives. Real cool. You didn't have to reboot or anything. You plug it in, it automatically recognizes it. You could boot off of that even. I don't remember why, but they had 2 computers at each student workstation too. In theory, if you have that swappable drives, you don't need that. But maybe if you just have one that you want to be the suspect's computer, you go to the other one, you make a copy, you take that swappable hard drive, you plug it in, boot off that hard drive, and you're got the same environment as them. Simplest method is to use a tool that makes a direct disk to image copy. Examples of disk to image copy tools: Linux DD command, ProDiscover, Voom Technology Shadow Drive. ProDiscover's been around a long time. I don't think I've heard of Voom Technologies. Voom Technologies. Shadow Drive. Shadow 3. Immediate forensics investigation on site or in lab. Boot and operate a suspect computer without changing hard drive evidence. Boot and operate Windows, Linux, Mac, any operating system. Run any application on a suspect computer. Operate DVRs and game consoles of boot SATA. Minutes to connect. Investigation without limits. Present live in court. You always know it's expensive when they say request quote. Seems like it's geared more toward the court cases. Now, reporting. To perform a forensics disk analysis and examination of each graded report. We're not talking about something you have to type up yourself, but we're talking about using a tool of some sort. Subfunctions: reporting, bookmarking, or tagging. So when you do run across a file that is illegal, whatever form, you can flag it in some way. Say, hey, this I want to appear on my report. Log reports, timelines, report generator. So when you're all done, going through, doing all your searches. You got everything tagged, everything flagged that you want, and you can generate that report. And then you got your 20 pages of illegal child pornography. You take the court case and say, here's what we found on the hard drive. That's a good package. Does that. Considerations: flexibility, reliability, future expandability. That's kind of true in any software package, really. Create a software library containing older versions of forensic utilities, operating systems, and other programs. Create a software library. Sometimes it's a challenge to find older versions. They're real popular at the time. I suppose you can pay for them. You can order them off eBay and so forth. But I think I talked about that instructor here that wanted me to get some radio program running. Used to run on Windows 3.1 or something like that. And I tried to find a version of the operating system, Windows 3.1, couldn't find one anywhere legal. And checked with our IT department. They didn't have any copies of Windows 3.1. Who in the world would want it anymore? So I told them I couldn't find it. I could have probably bought one off eBay, but I don't want to spend the money. I'm sure there's a lot of legal copies out there, but I typically don't try to do things to get me fired. But yeah, having that software library available so you can access that is kind of important. Maybe they're running a real old version and of something, and they got the legal software on there. So you need that software, WordPerfect or whatever, in order to view it. You might think, well, that never happens. My uncle, he passed away maybe about 7 or 8 years ago. And it's probably about 10 years ago he stopped doing this. But he used to have a booth, I guess it was, maybe a table. I never was up there and never did see it, where he sold MS-DOS programs at a flea market. And he consulted with organizations. He considered a Windows a fad. It was going to go away. He thought everybody's going to go back to MS-DOS. And so I'm sure he had every MS-DOS program there was. And, if you were doing something on that, well, I suspect nothing we have now would have a viewer such you could view that. So again, having those available. If you're in law enforcement, if you're down in Arc City, I don't think it's necessary. If you're up in Wichita, I bet you find everything under the sun computer-wise up in Wichita. If you get a larger city, that's, you have to keep in mind, you wouldn't create a software library like this if you're in a small town. If you can't analyze something, you send it off to another lab. Okay, following sections explore some options for command line and GUI tools in both Windows and Linux. First tools that analyze and extract the data from floppy disks and hard disks were MS-DOS tools for IBM PC file systems. I remember Norton Disk Edit. That was a fantastic tool. That was one of the first MS-DOS tools that you could use they say for computer investigations, but it was also to recover data and a lot of other utilities. Command line tools require few system resources, designed to run minimal configurations. Unix was big when it first came out. Now you hardly ever hear the word Unix, except for people that have been around for quite a while. It's been mostly replaced by Linux. It says you might still encounter systems running Unix, and there's not a whole lot of difference in case you're wondering. Linux has got a few more system utilities, but pretty much the same ones I was using. Good Lord, it has been 25 years ago. Same ones I was using 25 years ago, or same ones you're using now. Linux platforms have become more popular with home and business end users. They got a graphical side to them. This coming Saturday, I am having a workshop in here, 9 to 12. I'm sure everybody would want to come spend their Saturday morning doing that, but it's on Linux. So if you never used Linux and you want to learn about it, then you can come to that. There'll be a variety of people here. They won't necessarily be computer science individuals, so might be boring to you, but you're welcome to come. If I click activities, it pops up with these here, and I can choose this. Gives us a graphical, so that's what we're talking about. A lot of the stuff you see in this package is just as user friendly as Windows. Here's the software that's installed. Maybe it's the software you can install. I usually make this bigger for the Linux class, but I didn't do that to start with. So, show applications. There it is. There's LibreOffice Calc, if that's what that says. It's a little spreadsheet you could use. So again, just user friendly. Ubuntu is probably the most user-friendly one. I don't think Fedora is. The reason why I'm showing Fedora in that Linux class is if you're going on to Wichita State, Fedora is one they focus on. And I want people going on to Wichita State, if they are, to be as ready as they can be. It's frustrating. I started a computer science class at my junior year. Programming one's a nightmare, but there was another one where they expected me to know these Unix commands. I'd never used Unix in my life, and it was a challenge because I didn't have any kind of clue what I was doing. That was a programming class that introduced us to a lot of different languages like Ada and Lisp and all those. So I had run some of them on Unix. Smart, designed to be installed in numerous Linux versions, can analyze a variety of file systems with Smart. Many plug-in utilities are included with Smart. Another useful option in Smart is its hex viewer. I've never used that. Helix 3, one of the easiest suites to use. You can load it on a live Windows system. Loads as a bootable Linux operating system from a cold boot. Some international courts have not accepted live acquisitions as a valid forensics practice. Sometimes it's a challenge to get a bootable Linux that's easy. They've improved quite a bit. I forget what one it was that you could install Linux on your Windows and run it. It was just a nightmare. Kali Linux, formerly known as Backtrack, includes a variety of tools and has easy to use KDE interface. Autopsy and SleuthKit. I've used Autopsy. Yeah, I've used SleuthKit also. So the SleuthKit is a Linux forensics tool, and Autopsy was a browser interface used to access SleuthKit's tools. Chapter 7 explains how to use those tools. Force point threat protection. Never used that before. Formerly known as Second Look, a Linux memory analysis tool, could perform both on-site and remote memory acquisitions. GUI forensics tools can simplify digital forensics investigations. Just makes them easier. Anything GUI is easier. Not more powerful, just easier. Have also simplified training for beginning examiners. Most of them are put together as suites of tools. Advantages, ease of use, multitasking, no need for learning older operating systems. If you use Kali Linux, it appears like it's a GUI, but then a lot of the programs you run will take you into a terminal window where you're expected to do all these commands and all the parameters and so forth. And that's frustrating because you want a nice GUI you can just click around and do it in. At least I do. Disadvantages, excessive resource requirements, produce inconsistent results, create tool dependencies. Investigators may want to use only one tool, should be familiar with more than one type of tool. Technology changes rapidly. Hardware eventually fails. Schedule equipment replacements periodically. When you plan your budget, consider amount of time you expect the forensics workstation to be running, failures, consultant vendor fees, anticipate equipment replacement. Got to keep up to speed on it because computers keep evolving, keep changing. Carefully consider what you need. Think of your categories. Is going to be a stationary workstation, desktop sitting there? Do you need a laptop? Do you need a lightweight workstation? Computer's ready to die. Too tired this morning. I guess I didn't plug it in. There we go. That's close. I remember a laptop I had at Coke. This was back in the dark ages. The laptop was as heavy as a workstation. And we took it home. Slow as could be. Most times I find it easier to just drive in the 30 minutes to work, fix a problem, and drive home than it was to use that. But again, a lightweight workstation. Balance what you need and what your system can handle. Remember that RAM and storage need updating as technology advances. That's probably not a bad place to stop. So we're going to continue there next time. So we'll go ahead and stop the recording.